Welcome to Math Novas. Today we are going to revise everything we've learned about the number system step by step to lock these rules into your long-term memory. Let's look at this chart to review the foundation. We begin with the most basic counting units, natural numbers. These simply start from 1 and count upward. If we take that exact same group and just add a 0, the category expands to become whole numbers. Next, we introduce negative numbers into the mix. Combine those with our whole numbers, and we form the integers. Beyond that, we have rational numbers, which can be written as fractions. Standing entirely on their own are the irrational numbers, messy decimals that never repeat and never end. Group all of these distinct categories together, and they form the real numbers, representing the full collection of values we've discussed today. Now, let's test that baseline. Question 1. Which of the following is a natural number? 0, -3, 5, or 2.5? The answer is 5. Natural numbers strictly start from 1, so 0 and negatives do not qualify. Let's move to question 2. Looking at this new set of options, which one is a whole number? The correct answer is 0. Whole numbers are just the positive counting numbers with 0 included. Mastering these starting rules ensures you are applying the correct logic to each number type, which is necessary before moving into more advanced operations. Question 3 adds a little friction. Find the integer among these decimals, fractions, and square roots. We can immediately rule out the decimal and the fraction, leaving us with our answer, -4. Integers include positive numbers, negative numbers, and 0, but their strict limitation is that they can never be fractional parts. Let's look at question 4. Which of these numbers is irrational? The square root of 2 is the irrational number. We know this because you cannot write it as a tidy fraction, and its decimal format never ends or repeats. Being able to spot these continuous, non-repeating numbers is a necessary skill for maintaining high precision in advanced physics and math. Now, question 5 tests how these number sets relate to each other logically. Pause the video for a moment, read through these statements, and see if you can identify the correct relationship on your own. The correct rule is option B. All integers are rational numbers. This works because any whole integer can easily be written as a valid fraction. For instance, the integer 3 easily translates to the fraction of 3/1. This overlap demonstrates the hierarchical structure of numbers. These nested rules allow one number to belong to multiple categories simultaneously. Now that we've cleared the individual questions, let's step back and map the entire architecture of the number system. Look how this diagram nests. Natural numbers fit inside whole numbers, inside integers, inside rational numbers. On the right, the irrational numbers form their own standalone group. Finally, draw a single box around everything representing the real numbers. Take a screenshot as a cheat sheet. Great job working through these practice questions. We will apply this exact foundation in the upcoming basic algebra lessons. Actively reviewing these nested rules is the most direct way to build strong mathematical intuition. Keep practicing, and we'll see you in the next lesson. Thank you for learning with Math Novas. Subscribe for more easy-to-understand mathematics lessons and continue your journey from basic math to advanced mathematics.